Hey, I'm Philip, and I just wanted to show my quick Mechatronics 305 project. I had a need for my train collection. I did not have a snow globe, and I wanted a snow globe that would be able to stay automated and to circulate the particulate in the thing so it would look like it was always snowing. So here we have our fully automated and computer-controlled snow globe train car for the Lionel train set. Hey everybody, I just wanted to bring your attention to the internal components that makes this super cool snow globe work. So our power supply comes in on these 3 metal rails of 22 to 25 volts of AC current. That is then comes up here to this bridge rectifier, which then converts it to DC current. It then goes to a buck converter, which is a efficient way of lowering the voltage to whatever you set it to. This one is set to lower it to 12 volts of DC current, so that provides us with a stable 12 volt current source. The 12 volts powers both motor controllers, as well as our next buck converter, which lowers the current down to 5 volts of DC current with 2 capacitors for a little bit more stability in powering the Arduinos. We have our 2 motor controllers, this one and that one. The one with the orange and black wires powers the pump, which circulates the particulate inside the snow globe. The one with the 2 green wires powers a fan, which keeps the interior cavity cool. A couple things to bring your attention to directly on the computer chip with the Arduino is this light sensor right here, which helps the Arduino decide what the target temperature is. There's also a temperature sensor. It's really hard to see, but it's right next to that black wire, as well as an LED and a buzzer. Over here we have our user input, which internally looks like a potentiometer. And here we have our LCD screen. Just to show you how this all works when it's turned on, you're going to hear a buzzer, the buzzer go right as it says calibrating on the screen. Next we have our screen, which shows the current agitation level as well as the target level, the temperature, and the target temperature, along with the speeds that the 2 motors are being driven at. To show you the changing of the light sensor, as you can see, target temperature went up to like 100, the light goes away, it drops down. If I put my finger over here, it goes up to 100 and then it drops back down. Next we'll show the temperature sensor, and as the light is turned on, go again, it will raise the temperature, and then it will cool back down. When it's above, we will see that the fan is running until when it is below the target temperature, then the fan turns off. When it turns back on, that is a proportional loop. So it calculates the error based off the desired temperature, which it decides based off how much light it receives through the photoresistor, and then turns the fan on and off accordingly to cool the interior cavity of the chamber to the desired temperature. And there, one last thing. Sorry how the turbidity sensor works. Here we have an IR LED. It emits light, which then travels through the water, and based off the refraction from the particulate, there is a certain amount of the light that makes it back to the receiver on the other side, and that provides a stable reading varying from about 100 to a little over 900 on our Arduinos, which is well inside the usable range. And there you go, that's the inside. Demonstrate the LED changing real quick as I switch the user input. You can see it change based off of what I do with the user input. Here's just one quick video of the PID loop as it works. Try and maintain 9% target value. You can see that oftentimes it is able to maintain that exact 9% with by turning the pump on and various speeds in that PID loop. And here is a quick recording of the PID loop at about 22%, as it has just a little bit more agitation and it's a little bit easier to see. And now for the part you've all been waiting for. For the part you've all been waiting for.